All right, this is the lesson 3 through 5 reteach. Okay, so things to remember, these are reminders when we're talking about independent and dependent variables, that the independent variable represents X. Okay, and remember, independent is our input. Okay, the first question you ask yourself always is there time in the problem? Time is always independent, okay? And then these are our keywords down here that mark time. Hours, minutes, months, days or nights, weeks, years, seconds, anything that has to do with time. So the first question, is there time? If so, that's going to be my independent variable. Okay, second thing you ask yourself is about the dependent variable. Okay, so the dependent variable is the Y variable, okay? And this is your output, okay? So the second question you ask, is there money, okay? These are always dependent, okay? So when we're talking about money, sometimes you see the word totals too to remind you that that's the total amount someone's earning or spending or selling, whatever. Keywords for money: pay, spend, dollar, sell, buy, earn. You might see just the dollar sign, etc. So those are the first things you're asking yourself. 1, is there time in the problem? 2, is there money? Okay, so always refer back to this while you're working. Okay? So this looks a little bit different than your other notes because we're kind of forcing you to ask yourself these questions. Okay, so there's going to be some circling involved. Number 1, the Field Museum costs $8 per person to visit. Write an equation to find the total cost. Is there time in the problem? I don't see anything that has to do with time. Hours, minutes, months, anything. So I'm going to say no. Is there money or totals in the problem? I see the dollar sign. I see the word cost. Yes, there is money. Money is always dependent. So I'm going to go down to my dependent variable and I'm going to put a dollar sign right away, okay? So I need to know, is this money spent? Is it money earned? Is it the cost of something? Okay, so it says the Field Museum cost $8 per person, and then it's asking me what is the total cost, okay? So I know I'm talking about the amount of money it costs to go somewhere. Okay, so like we said, this is our dependent variable, which is our Y variable, okay? So now I need to look for my X, or my independent variable. So the amount of money it costs depends on what? And what that depends on is how many people visit, okay? It costs $8 per person. So this is the number of people visiting. Okay, I'm actually going to add the museum. Okay, so if we put this in a full sentence, it would say the amount of money it cost depends on the number of people visiting the museum. Okay, so my equation always starts with Y equals. Okay, then I'm going to go back into my problem and find the number. Okay, so as I'm looking through, I have 8 right here. Okay, so I know I'm going to have 8 in my equation. I'm going to look for my keyword that tells me what operation to do, which in this case is per. Okay, per means multiplication. So it cost $8 times the number of people. And the number of people is represented by X, so I'm going to write this as Y equals 8X. So again, this can kind of be like your sentence. Y, which is your dependent variable, the amount of money it costs depends on the number of people visiting. Okay, so that's my equation, Y equals 8X. Number 2, Katie is driving at a speed of 55 miles per hour. Write an equation to represent the total distance traveled. Okay, so the first question I'm asking myself, is there time? The answer is yes, because I see the word hour. Okay, So I know that time, I'm gonna scooch up here, is an independent variable. That's my x variable. Okay, so I'm gonna label my independent x, and I'm gonna say number of hours, okay? And then what depends on the, is there money or total? I'm gonna say no, this is not involving money, okay? So my dependent variable, what depends on the number of hours? Okay, so first you're traveling a certain number of hours. We wanna know the total distance. Okay, so the total distance traveled is gonna depend on the number of hours. So I'm gonna say total, actually I'm gonna say number of miles because it does tell me in my problem the distance we're measuring in miles, okay? So the number of miles depends on the number of hours. Okay, for my equation, again, I'm always starting with y equals, okay? I'm looking for the number in my problem, which is 55, okay? And it says I'm driving 55 miles per, which tells me multiplication, hour, okay? So my equation is 55x. 55 times the number of hours is going to tell me how many miles I drove. Right, so now we're bringing it all together. Okay, we're going to label our independent or find our independent and dependent variable. We're going to write our equation. We're going to fill out a table, graph, and then we have some questions down below. Okay, so remember, it's really important that our equation and our variables are labeled correctly because that's going to affect the rest of our problem. Okay, so Robin set up a used CD stand outside of her house and charges $3 for each CD. Write and solve an equation for the situation. Then make a function table for the total amount of money earned and the number of CDs sold. Okay, so I'm going to go right ahead and I'm going to label X, I'm going to label Y, and I'm going to ask myself, going back to the front, is there time involved? No, I don't see anything that has to do with time. Okay? Is there money involved? Yes, I can see that she charges a certain amount of money for every CD she sells. Okay, so money is a dependent variable. Okay, so if she's charging money to people, Robin is earning the money. Okay, so she's charging other people, so Robin is earning this money. So my dependent variable is the amount of money earned. Okay, what causes her to earn this money? What's our independent variable? Okay, she earns money based on the number of CDs she sells. Okay, so the number of CDs sold. So my independent variable is number of CDs. If I put this in the sentence, the amount of money earned depends on the number of CDs, sold. Okay, and that makes it a complete sentence. For my equation, again, I'm always starting with y equals. I'm going to look back into my problem to find the number. Okay, I see a 3, so I'm going to circle that. I'm going to look for my keyword, which is each. That's the same thing as saying per, so I can say for each CD or per CD, which means I'm multiplying, okay? And it's 3 times the number of CDs. CDs is X, so it would be 3 times X. Y equals 3X, okay? So I am going to copy that equation into my functions table. And I know for my inputs, it's easiest to always just choose 0, 1, 2. Okay, and then I'm going to plug in those values for X. Okay, so I have Y equals 3 times 0. I'm plugging in 0 for X. Can either do that in my head or type it into my calculator. 3 times 0 equals 0. Okay, so that is my output, y equals 0. I'm going to look at my x and my y value, my input and output, and that's going to be my ordered pair, 0, 0. Next, I'm going to plug in 1 into my equation. So I have y equals 3 times, I'm going to plug in 1 for x, 3 times 1 equals 3. So that's my output. My ordered pair is 1, 3. Okay, and I'm going to repeat for 2. So y equals 3 times, plugging in 2. 3 times 2 equals 6. That is my output. My ordered pair is 2, 6. Okay? Very important thing to remember. I need to label my graph. So this is my x-axis. I'm going to look back up here. X is number of CDs sold. So I'm going to go ahead and label number of CDs sold. Y, my y-axis, Y is dollars earned. So I'm going to label that dollars earned. Okay, and then I'm going to go ahead and plot my points. So I have 0, 0. I have 1, 3, so over 1, up 3. I have 2, 6, over 2, up 6. And I forgot to bring my ruler over here. So I am going to connect my points with a ruler. And remember, I have to draw an arrow at the end because this would keep going. If she sold 3 CDs, 4 CDs, so on. Okay? Now we are going to move down to part A and part B. Okay? So part A says, if Robin wants to make $63, how many CDs does she need to sell? So we need to think to ourselves, which variable do we know? I'm going to circle the number. Okay, I have $63. I am going to look back up to what I already filled out. So which one of these is talking about dollars, X or Y? I can see that Y is talking about the number of dollars. So the variable that I know is the Y. Okay, Y equals 63. Okay. My equation, which again, we've already figured out and written up here, is y equals 3x. Okay, so my equation is y equals 3x. I am going to be plugging in 63 for y because that's the value that I know. Okay, so I'm going to do 63 equals 3x. I need to know the number of CDs. How many CDs? I don't know how many CDs. Okay, so to solve, I'm going to divide by 3 on both sides to get x by itself. Okay, and 63 divided by 3 is 21. Since this is a word problem, make sure you're labeling. We already talked about it. How many CDs does she need to sell? She needs to sell 21 CDs. So I'm going to label that as 21 CDs. Okay. Part B, how much money would Robin earn if she sold 15 CDs? Okay, so I need to figure out which variable I already know. I know my equation is y equals 3x, but do I know what the x equals or do I know what the y equals? I'm going to circle my number. She sold 15 CDs. CDs is, if I look back up, number of CDs is my x variable. Okay, so I know that x equals 15. So when I'm solving, I'm replacing x with 15. Okay, so I'm going to write this as y equals 3 instead of x times 15. Okay, if I plug that into my calculator, I will get y equals 45. And again, this is a word problem. It's asking how much money. So the answer should be $45. If she sold 15 CDs, she would make $45. Okay? Question 4. Okay, again, I'm going to start by labeling. I have X is independent, Y is dependent. Okay, so John and his friends are going bowling. It costs $9 per game. Write an equation to represent the total cost. So I'm going to ask myself, is there time in the problem? If I look at this, nope, nothing that has to do with time. Is there money in the problem? Yes, it's talking about the cost. Okay, so it's asking what the total cost is. So I know this has to do with money. Okay, so that is, like it shows in your table, your dependent variable. It comes second. It's your Y. Okay, so we're going to say the money that John, so John is going bowling, the money that John spent. Okay, he's not earning money, he's spending money because he's going bowling. Okay, what determines the amount of money he spends? What's causing him to spend this money? What comes first? Okay, so if I look back in my problem, it costs money per game. So the number of games he plays is going to determine how much money he spends. So number of games played. Okay, so again, test it in your sentence. The amount of money spent depends on the number of games played. Okay, so I'm going to go ahead and write my equation. My equations always start with Y equals. I'm going to go back into my problem and look for my number, which is 9. I'm going to look for my key word, which is per. Per means multiplication. I'm doing 9 times games. So 9 times the number of games, which is my X variable. So this would be Y equals 9 times X. Y equals 9X. Okay, so I'm going to copy that down into my function table, Y equals 9X. Again, easy to just pick 0, 1, 2 for my inputs. Okay, and then I'm going to plug each of these in. Okay, so Y equals 9, instead of X, I'm plugging in 0. 9 times 0, which equals 0. So my input is 0. My ordered pair is 0, 0. I'm going to plug in 1, so Y equals 9 times 1, which is 9. My ordered pair is 1, 9. Okay, and then I'm going to plug in 2. Y equals 9 times 2, which is 18. So my ordered pair is 2, 18. Okay, so right away before I even start plotting my ordered pairs on my graph, I'm going to label. Okay, we're so nice and we gave you the X and Y labeled on your axes, so you don't even need to try to figure that out. So I find my X, I go back up here. X is number of games played, so I'm going to label number of games. Oops, sorry, you can't see that. Number of games. Okay, Y, if I look up here, Y was the money spent, so I'm going to label that money spent. Okay, and now I'm going to plot my ordered pair. So I have 0, 0. I have 1, 9 over 1, up 9. And I have 2, 18 over 2, up 18. I'm going to take my ruler. I'm going to connect my ordered pairs. And I'm going to draw my arrow at the end because it keeps on going. Okay? Part A. How much money would John spend if he plays 6 games? Okay, so I'm going to copy down my equation right away, Y equals 9X, and let's figure out what we know. Okay, so my number is 6, and the unit is games. So we know he played 6 games. Again, if you're confused, double check what you put up here. Number of games is X. So we know that X equals 6. So I am going to be plugging in 6 for X, okay? So when I plug that in, my equation will look like Y equals 9, and then instead of X, I'm plugging in 6, so 9 times 6, which means Y equals 54. This is a word problem, so I need units. I was trying to figure out how much money he would spend, so my answer would be $54. Okay? How many games could John play if he has $45 to spend? Okay, so I know my equation, still working with Y equals 9X. Okay, what do I know? My number is 45, and the unit it's talking about is dollars, $45. So again, I can check up at the top. Dollars was my Y value. Okay, so I know that Y equals 45. Okay, so I'm plugging in 45 for Y. Okay, so instead of Y equals, I'm going to start with 45 equals 9X to solve. I'm going to draw my line. I want to get X by itself, so I'm going to divide by 9 on both sides. Okay, so 45 divided by 9 is 5. Okay, it's a word problem. I need a unit. It's asking how many games. So my answer is 5 games. All right, go ahead and move on to your homework.